Assalamu alaikum and welcome. Pressure drop in strainer is the most important factor. When fluid passes through the strainer screen, the flow area will reduce and velocity will increase and friction losses will also increase. This effect causes the pressure drop. If now the pressure drop is high, the pressure in section of the pump will reduce. It will increase the cavitation risk. It will reduce the system performance. There are a lot of factors that affect the pressure drop like fluid flow rate, viscosity of the fluid, mesh size, open area in percentage, dirt accumulation inside the strainer, and size of strainer by itself. There are two methods to measure the pressure drop across a strainer. One is Van der Graaf measurement, one is theoretical or through a K formula. Let us discuss one by one. First one is Van der Graaf method. It is most reliable and industrial preferred method because each strainer has unique geometry. It differs flow pattern. Area opening of is different. First one is Van der Graaf method. This is most accurate, real world and industrial preferred method because each strainer has unique geometry. The open area of mesh is different. The flow pattern differ inside each strainer. K value change with Reynolds number. Therefore, each strainer has separate laboratory testing based graph. You can see graph on screen. In x-axis there is a flow rate in GPM or meter cube per hour, and on y-axis this is differential pressure. First step to identify the strainer size and its type, because if you will see inside the scanner different lines are drawn. All lines are for separate strainer size. So first step is to identify the strainer size and point out that line inside the graph. Then second step is to read graph from x-axis, the flow across that line. Then in third step you have to mark it on vertically a y-axis. Now read the value. This is a way to find differential pressure across a strainer for each size of a strainer. This graph is basically for water, standard water. If you have to calculate for unstandard or non-standard, you have to calculate it by formula. Second is formula method or K value method. This method is used during preliminary engineering or initial stages for cost estimation. The basic formula you can see on a screen, dP is equal to kV square rho upon 2. Here K is the loss coefficient, dP is differential pressure, V is velocity, rho is the density. In step 1 we have to calculate the velocity through effective area, open effective area. Formula is Q is equal to VA, flow rate is given Q, V we have to calculate, area is given for each strainer opening. You can see on screen. Okay, viewers, you can see here I have developed a simple sizing sheet for pressure drop calculation. This is the when given data, fluid density, viscosity. This is the flow rate in meter cube per hour. This is size of the pipe in which Y type strainer is installed, and this is the pipe schedule. I've listed down here across the each size according to schedule the ID of pipe in meter. Okay, this is the mesh size. We have different mesh size from 20 to 100. Okay, it will be according to our requirement. And this is the open area. For each mesh size, we have different open area. I've listed down this thing. You can find this from any practice or vendor graph for mesh size calculation. Okay, this is the open area, and this is blockage. Now this is fresh, strainer is fresh, so this is 0. Effective area will be equal to total open area. So now these are the calculated values: meter cube per second flow. This is the pipe area. This is the calculated velocity across full pipe area. Now we have to calculate effective velocity across the effective area only, that is 0.2%. Okay, this is Reynolds number, and this is K coefficient that we are using for Y standard. Typically we have K from 3 to 5, so we are using here 3. Then pressure drop will be 25. Okay, if we are using 5, then it will be 42 across the strainer with this flow. If we increase the flow, the things will be 1 meter cube per hour. Okay, or we can see here blockage. We are considering 50% blockage. Dirt is accumulated in strainer, and now what will be the pressure drop? See, this is the pressure drop across filter when 50% dirt is accumulated. If it is 10%, then pressure drop will be less. So this is the simple data Excel sheet I have developed for you. You can see on screen the comparison table between these two methods, Venn graph method and formula method, for better understanding. It is common saying in engineering that in early stage formula guides you, but in final stage vendor data protect you. In process engineering, this standard seems to be very small and not important for most of the people. But this is protecting $100 million equipments. Thank you very much. Please subscribe and share to support the channel.